Our next speaker is Geneviève Massonnet. Dr. Massonnet holds a Bachelor of Science as well as a doctorate in forensic science from the University of Lausanne in Switzerland, where she is currently an assistant professor in the Forensic Science Institute. Her research covers a broad spectrum of interpretive and analytical problems relating to various areas of trace evidence. And today, Dr. Massonnet will be discussing with us her work on evidence interpretation in a case involving household red paint.
Thank you very much, Cassandra. Good afternoon, ladies and gentlemen. First, I would like to apologize for my English, as I'm amongst the few people here which are not English-speaking person, so I hope that you can understand me. This is about the case we had in Lausanne. It's a very small case, but it will show you how you can give some data interpretation about it. So what has happened? In two different locations, there were bottles, beer bottles filled with red paint that were thrown on public buildings. 4 months later, a suspect was apprehended, and he was at the time throwing a bottle of beer with orange paint in it on another building. And so there was some kind of link with the two precedent cases. And the police went to his apartment and found shoes with red paint traces on it. We were asked to carry out comparative analysis between the red trace found on the shoes and the two red paint found close by to the two different locations where the paint were thrown. We use an analytical sequence which includes microscopy, optical microscopy, infrared, and Raman spectroscopy. And the judge also asked us to give the interpretation of the case, just if we had a match. This is the first debris that were found on the first location, Building 1, in June 2007. You can see partly the beer bottle and the red paint. On the second building, in June 2007, also some glass and red paint. And finally, in October 2007, the suspect shoes with several paint traces on these shoes, red paint traces. Using microscopy, infrared, and Raman, we found that the paint at the location 1 was an acrylic paint, and it contains the pigment red 112, according to the color index. This is a measurement done by Raman spectroscopy. The traces on the suspect shoes were also acrylic, containing the same pigments, and those spectra were not differentiated. On the opposite, the paint on Building 2 is an orthophthalic alkyd with calcium carbonate, and it contains the pigment red 170. So there is an exclusion of common source between the Building 2 and the trace found on the shoes. These are the infrared spectra. On the top, the trace on the shoe, then the Building 1, then the Building 2, and you can see that there is a correspondence in the infrared spectra with Building 1 and a complete difference with Building 2. For the Raman spectra, the first spectra is the trace. It corresponds to the pigment red 112. The second one comes from the Building 1. It's also the same organic red pigment. And for the Building 2, you have another organic pigment, which is the pigment red 170. So again, there is a correspondence between the trace and Building 1, and nothing similar with Building 2. So no, the judge was asking us, what does it mean? So we have an analytical match between the trace and Building 1, no correspondence between the trace and Building 2. To start with the interpretation, we were needing frequency of occurrence of the characteristic we had measured on the paint. So we started with a maquette study and built a database of red paint. We also look at the literature, and we use all those information in the Bayesian framework to give the interpretation of the analytical match that we had. First, we selected a specific red color, which corresponded to the red found on the 2 building places and corresponded as well to the trace found on the shoes. It corresponds to a code which is an aerial code used for the industry, and this aerial code is the code 3000. So we went with this code into shops to look for household paint which had exactly similar code or similar color. We found in the area where, in Switzerland, 28 domestic red paint with approximately the corresponding color. This is the preparation of the samples. You can see on the macroscopic slides, they have rather similar color, so they are difficult to differentiate by naked eyes. We did the infrared and the Raman analysis. These are the infrared results. So we try to identify the binder, the presence of calcium carbonate or no calcium carbonate, styrene, and then the organic pigments. Some of the bands were seen in infrared, and it was also used, the pigments were identified using Raman spectroscopy. What you see in red is the pairs of samples that were not differentiated using infrared. So you have 4 undifferentiated pairs of red paint just for infrared. We had also 12 autophthalic alkydes, so we did the same type of spectral interpretation and grouping, and in this case we have 1 undifferentiated pair. When you're trying to identify your spectra and trying to put them in a table, it's a rather long process, and if you add a new sample, you may completely change the way you build your tables, because then you will have a new elements and you will have to change everything. So it's not the best way of dealing with a large sample set. But it does help to visualize what type of component of chemical composition you have in your samples. That's why we continue with those samples and try some chemometrics grouping. And these are the results of a master project of one of our students this year. So this is the 2 principal component analysis. You have the PC1 and PC2, PC1 on the x-axis and PC2 on the y-axis. And you can see that this statistical method first differentiate in your infrared spectra the presence or the absence of calcium carbonate. This is the main feature that is seen by the statistics. And then for the other axis, you have the differentiation between the alkyd and the acrylic. So you have really nice grouping of paint containing the same binder or the same extender. And this does help a lot, because if you have a new sample, it will automatically be classified in the correct position. With Raman, you see mostly the organic pigment in this case, and we have 5 categories of pigments with several samples or sample pairs that were non-differentiated by Raman spectroscopy, 10 undifferentiated pairs. Again, doing the chemometrics, you see a rather good grouping depending on the pigment contents of your spectra. So it also does help if you have new sample to classify or to control your identification. Again, the discrimination by visual comparison is lower than what you get by the statistic or the chemometrics, and this both has to be checked. If we consider only the visual part, we have a discriminating power for infrared of 0.99 and a little lower for Raman spectroscopy. Again, doing the chemometrics, you see a rather good grouping depending on the pigment contents of your spectra. So it also does help if you have new sample to classify or to control your identification. Again, The discrimination by visual comparison is lower than what you get by the statistic or the chemometrics, and this both has to be checked. If we consider only the visual part, we have a discriminating power for infrared of 0.99 and a little lower for Raman spectroscopy, 0.97. If we combine both techniques, there are only 3 sample pairs which are not differentiated. And remember that we try to look at exactly the same red color for those paints. So it's not bad. They were all household paint, and we have only 3 pairs which are not differentiated in this market study. This is too small that you can read this table, but the colors indicate the non-differentiated pairs. So you have the red color, the brown color, and the green color. For the red and the brown, there are different paints, both in different shops. But when you look at the importer of those paints in Switzerland, it is the same company, and those paints are both coming from Germany. So there is a possibility that the same paint was imported in Switzerland and sold under different names in different shops. We are not able to check this, but it can be an explanation of the very close chemical composition of this paint. It is not the case with the green pair, so in this case, it should be good to go to further analysis to try to differentiate those paints. If you have a database, you can give some information to the police about what to search. So in this case, for building 1 and the traces, we were able to say, well, there are corresponding brand name and shops and given paint that you can search in the suspect house. And for building 2 is the same. You have also this information about the brand, the shops. You can also ask the police to go to the shops and check at the credit cards, because if you buy something, there must be, if you use your credit card, then it will be listed somewhere. So if you are quick enough, maybe you will see how many people have bought such paint and which one could be a potential suspect in a case. So a database is useful to give information to the police if you need it. Well, interpretation. In the Bayesian context, you have to set hypotheses, and you have to choose the level you want to set your hypothesis. The first level is the source level, which tells you that the trace and the paint on building 1 have a common source. We found in this case that the morphology of the paint traces on the shoes were helping us to get to the contact level. There was a contact with the paint used against building 1 and the suspect shoes, versus there was no contact between the shoes of the suspect and the paint used against building 1. And we have to discuss both hypotheses. Under H1, we must control that the traces recovered on the shoes are compatible with the action of manipulating wet paint. And in fact, when you look at those traces, they cannot be smears or dry paint. It must have been wet and stick on the shoes. So a dry transfer can be excluded. It was a wet transfer. And we consider that the number, size, and configuration of the paint traces are consistent with the action of manipulating wet paint. We cannot say that he has thrown beer bottle on buildings, but we can say that he has been manipulating wet paint. Under H2, you must have the suspect story. How does he explain these red traces on his shoes? If he's telling you, well, I've been repainting my house with red paint, then maybe you will have to look there and to sample some of those red paint in his house and try to see if it does match or not. But in this case, he had no explanation, so we could consider that those paint traces were on the shoes by chance. And in the literature, there are very few surveys on paint smears on clothing or on shoes. There are two of them. One is in Canada by Lowe et al., and the other one is quite old now, is the one from Pearson in Great Britain. But still, they are the two sources that you can use. If you look at those articles, you will see that on 164 pairs of shoes, only 15 fragments of red paint were found, and their size was less than 1 millimeter square. And only 2 pairs were having more than 12 fragments. So the number and the size of the trace we have in this case is a lot larger than what you can find by chance in the population. Pearson is telling you that 26% of the paint found on men's suits is red, but to find a paint sample bigger than 2 millimeter you have a chance of 1%, of less than 1%. So if you consider those two surveys, the probability to find about 50 red paint traces on shoes can be considered as rare. And giving the data we have, it's less than 1%. Now we can use the frequency distribution we have found in our market study. In our case, we had 2 red paint corresponding with infrared and Raman to the paint found on the suspect shoes, so which give us a frequency of 7%. And according to Aitken and Taroni in their book in Statistics and the Evaluation of Evidence for Forensic Scientists, you can multiply the background probability and the frequency distribution, which gives you a global frequency of 0.07. If you would calculate the likelihood ratio, it will be of about 1,400. Usually I don't put those numbers in the report, but it's just to give you an idea of the numbers you could get. But the frequencies are important. You know that finding that much paint traces on shoes is rare, and your specific paint is rare as well. So in conclusion, we wrote that considering both the analytical results and the discussion, the expert opinion is that all the observed and measured characteristics strongly support the hypothesis that the suspect shoes were in contact with the paint used against building 1. And you have the other hypothesis versus the hypothesis that there was no contact between the shoes and the suspect and the paint used against building 1. And it's also important to note that no link was found between the suspect shoes and the paint used against building 1. If you ask me why do I write strongly support, it's according to the literature and the paper from Everett and Jackson and Lambert and McCrossan, the impact of the principle of evidence interpretation on the structure and content of statement. It's a verbal scale for trace evidence. So I thank you very much for your attention. If you have any question, we'll be happy to answer.
No questions for Dr. Massonnet? Thank you, Dr. Massonnet.